Ever wonder how your phone just knows what to do when you tap an icon? Or how Netflix instantly plays the right movie? Well, it's not magic. Today, we're going to pull back the curtain and break down the secret logic that powers every single app you use. So let's start with a really basic question. How does an app actually, think? When you tap Buy Now or skip Intro, what's happening behind the scenes that makes it take the right action? It all comes down to a set of rules, a kind of secret language made of pure logic. And believe it or not, it all starts with a concept you already know inside and out, just a simple step-by-step plan. Now, in the tech world, we call this plan an algorithm. And I know that word can sound a little intimidating, but it's really not. Think of it like a recipe, but it has to be a super precise recipe. The steps have to be in the exact right order. You can't pour the water before you boil it, right? And it has to have a clear endpoint, so the computer doesn't get stuck just stirring your tea forever. Order and a finish line. That's really all it is. I mean, just look at making a cup of tea. You follow these steps in this order every single time. You even make a little decision there in step 4 about sugar. And that right there, that clear sequence with a simple choice baked in, is the fundamental blueprint for how pretty much all software works. Okay, so you've got this great plan for an app, this perfect little algorithm in your head, but how do you actually sketch it out? How do you organize your thoughts so they're easy to follow before you dive into the really strict, unforgiving world of writing actual code? Well, that's where something called pseudocode becomes your absolute best friend. Seriously, think of it like an architect's blueprint for your logic. It lets you write out all your steps using simple English, structured, kind of like code, but without any of the stress of getting a comma or a semicolon in the wrong place. And this comparison here just nails the difference. Pseudocode is for us, for people. It's a tool for thinking, for focusing only on the logic of your plan. Real code, on the other hand, that's for the machine. It demands absolute perfection, because a computer can't guess what you mean. It needs every single rule followed to the letter. And just look at how clear this is. You don't need to be a coder to understand what this does. It just says, get a number, and then check a condition. And by the way, that mod 2 part is just a simple math trick. Mod is short for modulo, and it just gives you the remainder after you divide something. So if a number divided by 2 has a remainder of 0, well, we know it's an even number. It's just simple logic written out clearly. But a good plan has to be able to make choices and react to different things. And that brings us to the computer's version of a fork in the road. We do this all the time in our daily lives without even thinking about it. We check a condition, hey, is it raining? And then we take an action based on the answer. It's totally natural, totally intuitive. And this is pretty much exactly how that same decision looks in the world of code. It uses what we call a conditional statement, an if-else block, that tells the program which path to take. If the condition is true, do this one thing. Otherwise, do that other thing. This power to choose a path is called conditional branching. And this right here is the big aha moment. This is the secret sauce that turns a program from just a dumb list of instructions into something that feels interactive and, smart. It's the foundation of every decision any piece of software has ever made. But what happens when a decision isn't just a simple yes or no? What if you need to check multiple things at once to make your app even smarter? Well, for that, we're going to need a new set of tools. And those tools are called logical operators. There are 3 main ones you'll see everywhere: and, or, and not. You can think of them as the grammar for making complex decisions. And is strict. It requires everything to be true. Or is way more flexible. It just needs one thing to be true. And not is the simplest of all. It just flips the truth. Like, if not raining, then you can leave the umbrella. So let's see them in action. With the and operator, every single condition has to be met. No exceptions. Think about getting into a club. You have to be old enough and you have to have your ID. If even one of those things is false, the whole result is false. Sorry, no entry for you. But with the or operator, things are a lot more laid back. You only need one of the conditions to be true to get a yes. So if you finish your homework or you clean your room, you get to watch TV. The only way you lose out here is if you do neither of them. All right, let's put all these pieces together. We've got our plan, the algorithm, our sketch, the pseudocode, and our decision-making tools, the conditionals and logical operators. Let's see how they actually power the world all around us. And once you start looking for this logic, you see it literally everywhere. When you log in somewhere, the app is checking, is the username correct? And is the password correct? When you buy something online, it's checking, is the card valid? And are there enough funds? Even in a video game, the logic is simple. If player health equals 0, then trigger game over. This basic set of rules is the engine that makes our entire digital world run. This login example is just perfect because it pulls everything together. You can see the algorithm's plan, written out in that clear pseudocode. It uses a conditional, the if-else, to make a choice. And that choice is powered by the AND operator, checking two conditions at the same time. This is it. This is the secret recipe in action. So, the next time you use an app, just remember this simple, powerful logic that's humming away right underneath the surface. It's what gives a machine its street sense. So I'll leave you with this question. What's a simple plan in your own daily life that you could turn into an algorithm?